everyone, and welcome to Algebra 1. Today's lesson is 6.4, Elimination Using Multiplication. Today is nothing that you haven't already learned. It's just an addition to a situation where using elimination, our variables don't always add up to easily eliminate. So we're just adding a step in this lesson. All right, let's get started. Previous objective was to use elimination with addition and subtraction to solve systems of equations. And today we are going to solve systems of equations by using elimination with multiplication and then trying to incorporate those into real-world problems involving systems of equations. Make sure you get your objective down. There's no vocabulary for this section, but I do, again, want you to copy down the key concepts. So solving by elimination, we know how to solve by elimination using addition and subtraction, meaning that our variables are already lined up for us. But what happens when things aren't so easily lined up? What steps do we have to take? So let's get started. Multiply one equation to eliminate a variable. So I look at these two equations and I say to myself, well, if I have to use elimination, I can't eliminate my x's and I can't eliminate my y's. But when we multiply an equation, we're not changing the equation, we're just multiplying it. And again, it doesn't change the line or the direction of the line. So as I look at this equation and I see a y by itself, well, if I multiplied this whole top by 2, then I would have 2y, so I could easily eliminate. So when I multiply everything by 2, I get 4x plus 2y equals 46. And then the bottom equation, I don't need to change. So I've multiplied my whole top equation by 2, and now I can easily subtract. I get x equals, how do we get 9? When I solve, and then I'm going to plug it back in. You can plug it into any equation. I'll plug it right back in here and say that 4 times 9 is 36. So 36 plus 2y equals 46. Subtract the 36 from both sides. And I get 2y equals 10. So y equals 5. So my ordered pair is 9, 5. Again, the only thing that we are changing or adding to this lesson is the fact that we are going to have to set up a multiplier in order to use elimination to solve for x and y. So let's try another example. All right, so I look at this equation and I can't eliminate my a's and I can't eliminate my b's at this point. But again, if I multiply my top equation by 2, and it can be the top equation or it can be the bottom equation. It doesn't matter which equation that you are multiplying. So remember that. I know these last two examples, we've both multiplied the top equation, but again, it does not matter. So I have 4a plus 2b equals 38. And now, again, my bottom equation I'm not changing because by multiplying the top by 2, I can easily see that now I can eliminate my b's. So I have a positive and a negative, so I am going to add these together. I get 7a equals 8 since 35, so a equals 5. And then I'm going to plug it back in. 4 times 5 is 20, plus 2b's equals 38. Subtract the 20 from both sides. You guys are pros at this point on how to solve. 2b equals 18, so b equals 9. So my solution, where do these two lines intersect? They intersect at the point of 5, 9. All right, the next one, I believe, again, yes, it is your multiple choice question. So take a look at these and figure out, well, which one, what do I need to multiply my whole equation by to use elimination? Again, it's your whole equation. So you don't just multiply one variable by the by a number, it's your whole equation. All right, let's move on. Example number 2 is a little bit more intense because, as we see in the explanation, multiply both equations to eliminate a variable. Well, in this situation, 4 and 3 can't eliminate those x's, 3 and -5 can't eliminate my y's, but at this point I can't just multiply something to get it to eliminate. So this is where the least common multiple comes in. And you can decide to eliminate your x's or eliminate your y's. I'm going to start with my x's. In order to get the same variable, the same coefficient in front of the variable, what I'm going to do to this equation is multiply my whole top equation by 3 and my whole bottom equation by 4. And what happens is, when I multiply everything by 3, I get 12x plus 9y equals 24. Again, these two lines are exactly the same. I have not changed anything. My bottom equation becomes 12x minus 20y equals, let's see, 25 minus 2, 4, 6, 8. 100 minus 8 is 92, negative 92. Hopefully I did my math right. All right, so now you can see that I multiplied my top by 3 and my bottom by 4, and now I have x's that I can eliminate by subtraction. 9 minus these cancel out. 9 minus a 20y gives me 29y's. And let's see, I get 109, 10, 11, 12, 126. Let me grab a calculator, make sure I did this right. No, I didn't do something right. Let's see, 24 minus a negative 92. Oops, is 92. Oh, nope, 24 minus a negative 92. Oh, 116. So this is 116. I'm dividing that by 29, and I get 4. So y equals 4. So you can use a calculator when they get a little bit big and you can't do them in your head. And now we can substitute it into any one of these equations, again, because these lines are exactly the same. So I can bring this 4 way back up to the top equation if I wanted to. I could use the second, third, or fourth equation to substitute the variable. I'm going to put it into the top, so 4x plus 3 times 4 is 12 equals 8. And now I can solve. Subtract 12. 4x equals negative 4, so x equals negative 1. So these two lines intersect at negative 1, 4. All right, let's try another one. So I have 4 and 2, and I have 7 and negative 5. So I could multiply my whole top by 2 and my whole bottom by 4, or I could multiply my whole top by negative 5 and my whole bottom by 7. Again, it doesn't matter. What you're doing is you're finding the least common multiple, but either between your x's and your y values, and then you will multiply each equation. I'm just going to use my 4 and my 2, so I'm going to multiply the whole top equation by 2 and the whole bottom equation by 4. So I get 8x plus 14y's equals 60, and I get 8x minus 20y's equals negative 36 times 4 is negative 144. All right, now I have again set up my equation where I can use the elimination method. If you don't see this after you've multiplied your top and bottom equations, you've done something wrong. 8 minus 8 cancels out. 14 minus a negative 20 ends up being 36y's. And 60 minus a negative 144 is 204. And then when I divide that by 36, 60. Oh, I'm sorry, this is 34. Sorry, it's been a long day. So divided by 34, whoops. 204 divided by 34, and I should get 6. Yep, so y equals 6. All right, so negative 14 minus negative 20 ends up being 34, not 36. Divided that by 204 divided by 34, and we get y for 6. Again, you can plug these back into any equation that you choose. I will plug it back into the first equation. I get 4x equals 42, plus 42 equals 30. Subtract the 42, I get 4x equals negative 12, so x equals negative 3. My pen is being very glitchy now. Negative 3 and 6 is your solutions. All right, we are to the open-ended question. Again, it's nothing more other than finding that multiplier or that least common multiple to solve using elimination. So take a look at these two equations, figure out what you want to use as your multiplier, multiply both equations, and then solve using elimination, addition, or subtraction. All right, enjoy the lesson, and we will get to work tomorrow. Thanks and have a great night.